All right, so today we are going to talk about all things slope and lines. So thinking back to your Algebra 1 days, right, slope was a big part of describing how lines behave. So starting out at the beginning here, first let's identify what slope is. So slope is the steepness of a line. Okay, and there are many different ways we represent or talk about slope. And the first thing to remember is the variable we use to represent slope, and that is m. Okay. Now, another way you'll see it represented is delta y over delta x. And what that means is the change in y divided by the change in x. Now, we're going to talk about this notation a little bit later in the unit, and we deal with this mainly when we're talking about rates of change. Now, the most popular way we talk about slope, and you guys might remember this, is rise over run. All right, and the last thing we use slope for is the slope formula, which is y2 minus y1 over x2 minus x1. All right, so the different types of slope. We have 4 types of slope that we can talk about. The first one here is a line going uphill from left to right. So we would say that this is positive slope. Over here, we're going downhill from left to right. So this would represent negative slope. Now, the last two are our horizontal and vertical lines. So looking at the next one there, that is a flat line, so there's no steepness to this line, meaning that our slope would be 0. Now the last one there are on our vertical line. Vertical lines have undefined slope. Okay. It's not flat, so there is no steepness, and it's not going uphill or downhill. So since it's not any of those things, we say that it has an undefined slope. Now, there are a lot of problems that we can use slope for, and there's a lot of ways to find slope given different aspects of the line. So the first thing we're going to look at is finding the slope given a graph. So given a graph, I want to find 2 points. So if I look at my example over here, I see that I have a point here and a point here. So I have my 2 points. Now, some of the problems, the points will be given to you. Other problems, you're going to have to find 2 nice points. And what I mean by nice points is that it falls on our coordinate plane nicely. It's not in the middle of 2 lines or anything like that. Now, once we have our 2 points, we want to count the distance up and down. And that'll give us the rise. And then I want to count my distance left and right, which would give me my run. So looking again at this example, I'm going to count, and we always go left to right. That might be something worth writing down. We always go left point to right point. So starting at my left point, I'm going to go up 4, and I'm going to run or go right 3. So that would give me a slope, right? Rise over run. So rise 4 and run 3. Now, this is going uphill, right, from left to right, so that means it's positive. If the line is going down, so it has a downhill slope, then that slope is going to be negative, okay? All right, let's look at our 2 examples here real quick. So I have my 2 dots, and I want to create my line through those 2 dots so I can kind of see a little bit better what's going on. So this thing's going uphill, right? So it's going to be a positive slope. And starting at my left point, I'm going to go up 1, 2, 3, 4, 5. So I went up 5, so I rose 5. Then I have to run 1, 2, 3. So my slope would be 5/3. Now, we always want to leave slope as a fraction, right? Because that fraction represents how much I have to rise and how much I have to run. So I want to keep it as the fraction. Now, sometimes we'll get problems where we can simplify the fraction, and you want to always do that, but leave it as the fraction. Don't type that into your calculator and get a decimal answer. All right, looking at the next example, draw your line. Okay, so there's my line. Now, this thing is going downhill, right? So I know my slope's going to be negative. Starting at my left point, I'm going to have to go down 1. So this time I'm falling down 1. Then I have to run 1, 2, 3, 4, 5. So my slope would be -1/5. Doesn't simplify, leave it as the fraction, that's my answer. Now, sometimes it only gives us 1 point and the slope, and it asks us to draw the line. So from that 1 point it gives us, I'm going to take my slope, so I'm going to rise 2, and then we're going to run 3. So starting at my point, I'm going to go up 2/3. 1, 2, 3. And right there would be my next dot. Now, I'm going to continue this pattern to draw my line more accurately. So I'm going to go up 2 and over 3. 1, 2, 3. Up 2, 1, 2, 3. Now I can't keep going any further in that direction, but let's see if I can go in the opposite direction. So instead of going up 2 and right 3, I'm going to do the opposite to go backwards. So I'm going to go down 2 and left 3, which puts me there. So here is my line. All right. Now, the next way we can find slope is by using the slope formula. So to use the slope formula, I'll be given 2 points, and I'm going to label my 2 points x1, y1, and x2, y2. I would always start there, right? That way we can see what x1 is, what x2 is, what y1 is, what y2 is. Then I'm going to plug those values into my slope formula, which again, m equals y2 minus y1 all over x2 minus x1. And once I do that, we are going to reduce my fraction when necessary, okay? So example 1 here is already kind of worked out for us. So again, we start by labeling our points. So we have the point 0, 3 and the point -3, 1. So we label it x1, y1, and x2, y2. Then I take those values and I plug it into my formula. So 1 minus 3 gives me -2. -3 minus 0 gives me -3. Now, I have a negative over a negative. Remember, double negatives cancel each other out, right? And gives me a positive. So I want to simplify that down to just positive 2/3, and that would be my final answer. All right. So let's look at doing an example together here. So I have my 2 ordered pairs. I have the point 1, 5 and 0, 2. So I'm going to start by labeling. So we have x1, y1, and x2, y2. Now I'm going to plug into my formula. Okay, so y2 is 2, y1 is 5, x2 is 0, x1 is 1. So 2 minus 5 gives me -3. 0 minus 1 gives me -1. So I have -3 divided by -1. So that would simplify. Negative over negative would give me a positive number, right? And when we have 1 as a denominator, we're just going to write it as the number 3, right? 3 divided by 1 is just 3. So my slope would be 3. couple more examples here. So my two ordered pairs, I have x1, y1, x2, y2. Plug into my formula, y2 minus y1 over x2 minus x1. So y2 is 2, that should be y1, minus 5, all over 2 minus negative 1. Now, what happens when I have minus a negative number? That becomes positive. So I would have negative 3 on top. 2 plus 1 gives me 3 on the bottom. So negative 3 divided by 3 would leave me with negative 1. So my slope would be negative 1. All right, last example here. Label your points. x1, y1, x2, y2. Formula. So 4 minus 4 all over 3 minus negative 4. So on top I would have 0, and that's okay. Minus a negative, again, is going to become positive. So 3 plus 4 is 7. What is 0 divided by 7? Well, that would just be 0. So my slope for this line would be 0. It's okay to have 0 in the numerator. I can't have 0 in the denominator. So if we ever do a problem like this, and you work it down and you have something like any number on top divided by 0, that means that my slope is undefined. Okay, so keep that in mind. All right, so that's finding slope using the slope formula. Now, let's look at using an equation. So I can find slope from an equation in slope-intercept form. So if you think back to your years in Algebra 1, right? Slope-intercept form is y equals mx plus b. And again, m is my slope, and b is my y-intercept, where the line crosses the y-axis. So given an equation in slope-intercept form, it gives us a lot of information. So looking at example 1 here, I have y equals 4x minus 13. So comparing that to my formula up here, right? Here's m, and here's b. So my slope would be m equals 4. And my y-intercept would be negative 13. Now, if it's positive, we don't have to include the sign, right? But since it's 4x minus 13, that means the y-intercept is negative 13. So you have to include the negative if it's there. All right. Next one, y equals mx plus b. So m would be 1/2. My y-intercept would be 5. Last one, slope is 117. Y-intercept, 789. Now, we can graph from slope-intercept form fairly easy, so we'll go ahead and talk about that. So how we're going to do that, okay? So we're given the equation, y equals mx plus b. We're going to put a point on the y-intercept, okay? And that's your b value, right? So always start with your b value. That's going to be your first point. Then from that point, we're going to do rise over run. And again, that comes from my slope. So looking at this first example, it's already worked out for us, right? So the m is 2, and my y-intercept is negative 3. So again, remember, always start with b. So we plot that first point. So I go down to negative 3 on my y-axis, and I put my dot. Then from there, I'm going to utilize my slope. My slope is 2. Now, again, we want slope to be a fraction. So anytime I have an integer, like 2, right, I can always put a 1 on the bottom, just like we did here. So that means I'm going to rise 2 and run 1. So that's what they did. Up 2, over 1. Up 2, over 1. Up 2, over 1. Until we can't anymore. okay? So let's look at doing a few examples like that together. So example 2, mx plus b. So I notice there's no number in front of x. What number can I always put in front that won't really change anything? And that's the number 1. So my slope would be 1, but writing that as a fraction, I would have 1 over 1. And my b value, the number on the end, would be -4. So I'm going to go down to -4. And put my dot right there. Then I'm going to go up 1 over 1. So rise 1, run 1. Should be here. Up 1 over 1. And I'm just going to keep repeating. Going in the opposite direction, so down and left, just to finish the pattern. And that would give me this line right here. All right, number 3. So my slope is -1 over 2, and my b value is 6. Now, with the negative out front of my fraction, it doesn't matter if you put it on top or on bottom. I just always put it on top just because it's kind of easier to think about. So I make the 1 negative, okay? So let's go to +6 on my y-axis. So up to 6, 1, 2, 3, 4, 5, 6, put my dot. And then I'm going to go down 1 and right 2. So down 1, right 2. Down 1, right 2. And here is my line. All right, the last 2 problems here deal with my horizontal and vertical lines. So anytime I see y equals a number, okay, I want you to think hoi. Okay, so we have the y equals, right? Means it's going to be a horizontal line, which is this way. And my slope is going to be 0. Okay, so slope is 0. My b value is -5. So 1, 2, 3, 4, 5, put my dot. And it's a horizontal line through -5. So there's my line. Now, whenever I see x equals a number, I want you to think vux. Okay, so this is my vertical line, which is up and down. Okay, it's x equals, and my slope is undefined, hence the u in the middle of vux. Okay, so vertical, undefined slope, x equals a number. So my slope is undefined, and we can just say u and d for short. And it's never going to cross the y-axis, so there is no b value. So I'm going to go to 2 on my x-axis and put a dot and draw a vertical line. Okay. All right. The last little bit, we can now use the information we've learned above to write the equation of a line. So step 1, we're going to determine the slope. Okay, whether it be from an equation, it gives us it, we look at the graph and find it, or we're going to find the slope. Then we're going to determine the y-intercept. Okay, so we're finding m and b. Once I have that information, I'm going to plug it into the formula or equation, right? Slope-intercept form equals mx plus b. So looking at my first examples there, it gives me m and b. So I don't have to find anything. I already have both the pieces I need. So now I'm just going to write the equations. So y equals -2x plus 3. Now, 2, I see my slope is 0. So if you can already see where this is going to go, right, you can skip this step, but I'm just going to plug everything in. So I have y equals 0x minus 2, right? B is negative 2. Now, what is 0x? Do we write 0x? No, right? That's 0 times x. 0 times anything is just going to be 0. So this would really just be y equals negative 2. And again, that comes back to that idea of Hoy, right? My slope is 0, so think Hoy. Y equals a number. 3, we have y equals 1/2 x minus 3. And then 4, y equals negative 5x plus 0. But I'm not going to write plus 0, right? I'm just going to leave it as y equals negative 5x. Now, we're going to put it all together. Okay, so we are going to find the slope. Find y-intercept. And then write the equation. Okay, so looking at my graph here, it gives me the 2 points I need. So starting at my left point, I'm going to go up 1, 2, 3. So I rose 3, and I ran 1. So 3 over 1 is just 3. Now, my y-intercept is right here, and that is when b is 1. So my equation, mx plus b, so 3x plus 1. All right. Now let's look at another example of that. So find the slope. Start at the leftmost point. We have to go up 1 and run 2. So slope up 1 over 2. And my y-intercept is right here. So b equals 0. So my equation, 1/2 x plus 0. But again, I'm not going to say the plus 0 part, right? Next one, what type of line is that? Okay, that is a vertical line. So I want to think Vux. Vertical, undefined slope, x equals a number. So my slope is going to be undefined. There is no y-intercept, right? My line never crosses that y-axis. My equation, it's going to be x equals some number, so let's find where x is. And it's right here, when x equals 3. Last problem, negative slope, right? Going downhill. So starting at the leftmost point, I'm going to go down 1, 2, 3, 4, 5. So down 5 and over 1, 2. My y-intercept is right here at negative 3. So my equation, y equals negative 5/2 x minus 3.